Alright, we're getting back on the sportster motor now. I got everything stripped apart, put together obviously, get up on the jig here. So I got my mill rebuilt. It's a little bit quieter on the bearings. I had to zero the table back in, make sure everything was square there. And then I got this leveled out with my level. Now I got to go ahead and dowel indicate it in with my indicator. I did initial measurement of my bore here. And these spigots on these cylinders are like 3.997, so 4" and up should be good for clearance. So I measure them this way here, and we're 8.9 or something this way, and we're 4" this way. So looks like when they bored the case, they didn't tighten the bolt up in here or something. Even though the bolt was cut, but I don't know. Anyway, for some reason, whatever it is, the case they're now tight this way. They also screwed up when they bored and they cut this first here and they're sideways in the wrong spot. So you can see how that wasn't on this side. So they moved it over and recut it again. So that means they cut it. They did a little screw up there. So whatever, we don't care about that really, as long as it's got clearance. So I'm gonna go ahead and get this zeroed in here with the indicator. And then go ahead and bore this hole out and get things ready to go. Now I can't put my bolt in here because it overhangs up under here where the bolt would go through. So I went ahead and put the clamp here on the outside and put a little pressure on it to hold the case together like there's a bolt here. All the other case bolts are in right now, so they're sitting down here. They're already installed. Can't see the ones underneath in here, but they're in there. Got the trap door bolts in too. So the case is all pushed together like it's supposed to be. So I'm gonna go ahead and square this up, get going on it, and do that, and then we'll make sure these fit onto the case where they belong before we pull it off the stand. Unlike the last guy that didn't do that. That's why I always like having the parts I'm going to use on hand when I'm machining, and that way we don't have problems when things don't fit. You make sure they fit before you pull them out of the machine. Kind of important. So, alright, so first thing I'm going to do is get this thing over here closer. First thing I do is get the case leveled out. Then you go center of the case. It's a pretty good offset between two case halves here too. It's 4 thousandths there. We'll see how much it is on the other side. First problem is I've got way too much compression on this thing. Go and zero out my table. Alright. So we're going to clear all the dowel pins. Okay, that's 0 right there. 3.5 dowel undersize. Zero there and 2 undersize there. Got the interruptions again, I see. Hello. Yep. Yeah, what's up? All right. Alright, we're back. Interruptions as usual. Clunk. Okay, this is very uneven, so we're not sure what we're going to wind up with here for straightening it. We go 4 under and 3.5 over. So that gives us 7 thousandths total indicator reading, which is not very good. So that means there's a lot of warpage in this motor. So these cases are a long ways from being flat. So that means we got two things we can do. We can leave it, or I got to redeck everything off, which means I got to pull all these dowel pins out here, over here in the deck ties. I can't use the clamp, which is going to be a problem. I'd have to put the bolt in after I do the other stuff. So that will allow you to get a flatter surface. Now this being an axtell big bore motor, it's got an iron cylinder on it. Usually they don't run a gasket, just want glue down here, and glue will take up all the difference. Otherwise known as liquid snot. If you're using a stock style compression gasket, you're probably going to be a little bit flatter than this to make things seal. So either way, we're going to figure out what we're going to do on that. For now, I need to bore the center out. Appears to be being pretty flat. So now we come down and check our center point to make sure we're down low enough that we catch the good part of the bore here, not the bad part. We'll see how round this is. My guess is about as round as the rest of the motor. Let's see here. Nope, that don't work. We're below the surface. So that means we can't exactly make it a center dimension. When the case is bored wrong, it makes it hard to do that. All right. 5 under. It's 10 over. So we bring it back. Zero that out. Okay, zero that out. Now our one thou off that way. It gets tight again over here because they're not even beginning to be close. Right to there, we're 2 over. 0. Over 2, then flip to 0. 1 that way. Ah. 0 everything. Two. Goes to 4. What do we got? 1 over. Now we're about 0 that way. It's very uneven. Okay, I'm going to go up to the very top. See if we get this square. One thing it is not very round, let's put it that way. 4 that way, 4 that way, we're good that way. 1, it just drops away. Alright. We're going to call that square even though it's not even close to anything resembling a round hole. Of course, that's probably why it doesn't go together very well. Okay, we're going to use our big boring head, 4-inch one. All right. You have to set your depth stop here so you don't run into your machine or into the case, I mean. Okay, so that's where they bottomed it out at. Drop a little extra. Go in here. Cutting something. That's nice. Trying to get the cutter close and the damn thing's feeding itself up again from vibration. Try this again. So, see I was cutting right here. A little bit of fog right through there, maybe. Yeah, looks like it ended right there. I'm not seeing any cutting anywhere around here. We didn't cut anything on this side either. So it looks like we're only cutting right in that one little area. So we're going to go ahead and give this a couple thou more here. Make sure we tighten this down because it's moving on us. And we'll go ahead and try this again. That many RPM, whatever that is. Oh, about 1300. Making noise but not cutting. Okay, so that was a no-go. So loosen that up. We go in here and give it a few more thousands. Tighten it back down. At some point it's going to cut. Down, gauge at the speed. Handle starts to drop. Cutter goes down. And we're cutting. Here, two. I think it's got more in one spot, but I only see one spot right now. It's just starting to cut in here. It's not cutting here. It might be cutting right in this corner right here. Over here. Looks like it's barely cutting right here. You can see a little bit of the cut line here. So the case is pinched right here to here. So it looks like we need to move it over this way a touch. So we go over here and crank the dial over here a little bit. We'll give ourselves like a couple of thousands. Let's see, how much do we really need? We're not cutting anything over there yet anywhere. I think it's just foggy in this area. So I'll give it 2 thousandths even. Oop. Damn. Didn't want to move 2 thousandths. There's 2 up there. Okay, now we're cutting here and barely cutting here, so I'm going to move it 1 thousandths this way. So we do this with this handle over here, and that's that dial. There you go, 1 thou. So we got 2 in 1 movement. Okay, so now I'm going to go ahead and give this a little extra clearance. This is about 4 thou, 5. Give it about 4. I haven't measured the bore yet to see where we're really at, but we don't have really any place to measure yet, so I have to have a hole to measure with first. Okay, turn that on again. We're definitely cutting on the right side now, big time. I'm cutting over down the back a little bit. There we go, it's coming to the left side over there now. pretty even. Try and move it back another towel. Hit the stop here, click it off. Hit the brake. Okay. So now we got a round hole, more or less. Probably can go one thou more to the back here. This is that low spot that was cut wrong. And I'm thinking maybe we can probably come back on this other side a little bit also. So I'm thinking making them both in a thou and a half. Oop, not that much. Let's see, which way did I move it? Plus. Thou and a half. And move this handle back the other way. Half a thou. 6/10. Hey, one more. Too much. There we go. Ah, damn it. Ah, screw it. It likes being that number, let it have it. Okay. So now, have to measure the bore and see what we got. Take our caliper here. Get some kind of idea where we're at. So it looks like we're at 4 inches and 2.5 thousandths. Let's go measure it this way. 405, 406 right back in that area. That's because that's a low spot. Let's see, this is a front cylinder. This one here is the front one, as I recall. So these things are right out 4 inches. Okay, so that means we want 405 to 410 on our clearance. That'll give us 5 to 10 thousandths clearance in the bore here. So I'm only going to want to go a couple more thou from what we got right now. There's 2 thousandths. Tighten that down. Let's see what we get. Not much of a cut, obviously. Cutting back here like it should. Fogging over on the right side there, but doesn't look like it's cutting the forward edge. Up it is, you can just see it going down. Right there in that corner, see the line going down. It's hard to cut, only half a thou and a thou off in places. So we still haven't quite cleaned up this corner here yet, almost. I think the rest of the bore is pretty clean. Okay, so now we get our caliper out. Measure this again. There's 4065, that's almost what we had before. Biggest thing what do we got on this side? 4065. So I think it puts it about 5 thousandths clearance. And this one's right at 4 inch 1 thou roughly. 999. Okay, so we should be running about roughly between 5 and 6 thou clearance right now. So this cylinder right now should drop right down on this bore without a problem. And the problem is we got this clamp in the way, we gotta get rid of it. The next problem is our deck isn't even close to being flat, so My problem is, in order to fix it, I have to cut across this whole surface all the way across here. Scan, you know, cut completely across. And I don't have a cutter that does that very well. So I have to make 2 passes probably. Alright, let's put this back over here on the tripod. Go get our cylinder and see if it fits. We gotta figure out what we're gonna move. First thing to do is zero out our machine up here, our dial indicator. Okay, I'm gonna move my cutter this way. Take our clamp off. Snowing. And I have my bolt someplace. And go grab it. Okay, I'm going to put my cut down bolt in here. Just clears, good. Put my mark straight up where I always have it. What I didn't do is chamfer this edge yet, I gotta do that too. Okay, this is our new front cylinder. Screws go down all the way. Didn't have to beat on it or anything. Okay, I take a 1.5 feeler gauge. You see how that's in the air right now because it's sitting on that chamfer. See, it's not sitting down all the way. It's actually in the air right now, quite a bit in the air. That's why you have to chamfer that case out. Now, theoretically, if you have a gasket in there, it would take up the slack, but so these don't run gaskets. Okay, so now we need to pull some dowel pins out in order to do this, fix it. Now these are roll pins here, and dowels. Those are roll pins. So I don't have any to pull these roll pins out of here. Now without destroying them anyway. I have to think how I'm going to do that one. I don't think there's any way of doing it without destroying them. This one I can get out with a stud puller, or dowel pin puller I should say. Alright, let's move this over, get my dowel pin puller. There you go. One dowel pin puller. So that's the collet for it. So basically a big slide hammer, you got a big bolt, get a weight, you got a collet that's tapered, and you got the tapered piece here that jams in, locks the collet down. So all you do is tighten this up to get on into the bolt a little ways, and you lock it with this other piece. So you put it in the hole, down, give it a whack. Pull it out, dowel pins out. screws out. Okay, that was quick and simple. So those are the easy ones. The other ones are going to be a little harder. I can put a pair of vice grips on there or channel locks and try to rotate them without destroying them. Probably not going to happen that way. See, these come out with no damage because the collet doesn't do any damage to them. But you can see whoever did them before, they used probably did in a vise or something. You can see a big flat spot. These things are all chewed up, so whoever took them out before didn't do a very good job. Didn't have the right tool. Okay, now if you put something inside of the roll pin and put a clamp on it, a pair of vice grips, you can pull them out without damaging them, probably. At least that's the game plan. So we're going to use a drill bit. We have our drill assortment here. You find a drill bit that will fit into the, out of all the bits here, you find one of them that'll fit inside the dowel pin. Okay, that one is not big enough. That was 67 thousandths. So I'm going to try a 78. It's too big. So we're nowhere between 68 and 78. Try 73. That one is definitely tight. Okay, that's too much. So we're going to drop down to a 70, 3 thou smaller. And there we go. So that is the one we're going to use. So we're going to take our vice grip, we're going to adjust it and just clamp right up on that one little spot and pull it out. I'm going to use a rubbing block here, a piece of aluminum, and a screwdriver flat blade to get pressure on it. So that way I don't damage the case. So we don't want to be damaging the case and we can avoid it. Problem with this is we don't have room to get that in there. Can't get enough bite with that. Have to go something thinner. So a piece of thin copper here. Use that. It's not working. More pressure. Still not coming. Try even more pressure. There we go. So you can see how much came out there. Okay, now you go ahead and pop this off. So that's how long the dowel pin was, and luckily the drill bit still comes out. So I can reuse that because I haven't really damaged it any. Which is a good thing. So you want to make sure you got protection on your case, so you don't damage the case. It defeats the purpose of machining it flat when you destroy it, getting the stuff out. Just going to take a lot of pressure. I tried backing off of the pressure, it didn't help. So go back to more pressure. And it comes out. Drill bit still comes out, that's good. 2 down. Once you get the technique down, it goes pretty quickly. Just lost that one on the floor. See, I'm trying to do it where you can see it, so I'm not having any place to drop stuff. Yeah, well, I'll have to go hunt it on the floor. It's down by my feet somewhere. Good luck in finding it quickly. Alright, there's that one. Pop it off on a table this time. Alright, so that worked pretty good. So that's a 70 thou drill bit, which is a number 50 drill, if you don't know. So now you know what size drill bit you need. And a pair of vice grips. A good pair, not them cheap ones. You have to have the round, not the round style ones. So you make vice grips that are straight, wedge shaped, and then make them with big cut of round ones. Can't use the round ones, you gotta have the flat style ones. The round ones work good for bolts, but not for much else. Alright, so now we got that cleared off. So now I can go ahead and make a cut across here. And the only way I can do that, I'm going to have to use my fly cutter in here. This is a fly cutter. So this doesn't sweep enough, I don't think, to do it. Yeah, I can probably just about make that. So if I slide the bit out a little bit more, I might be able to make it work with this. Okay, I'm going to go ahead and put a little bit of a chamfer on this edge. There's another fly cutter I use. So this one I put a bit in here already angle ground to give me the angle I want for a chamfer. So we can do that. Just a matter of taking out your boring borer. And you put this in there. Check your cutter angle, let's see if it's anywhere near you want it to be. It isn't. Sharp. Okay, that's about 0. So when you adjust your cutter here, your offset for your cutter, you put your straightedge over here on the edge of the tooth, and you want it to be in line with your angle here, it's parallel to this hole. That way it'd be 0 offset, it'd be straight. The cutter itself has a slight offset, which gives you a positive angle cut on your bit. So if you don't know any of that stuff, you probably shouldn't be making your own bits. Angles matter. Hitting on something. Camera. Alright, move the camera out of the way. Go back to our 0 number. there. 0. Okay. Okay, now we got to cut the depth on this here. So we have to bring this down, adjust it to the height we need. Get that out of the way. Do your lock. Rotate it out until you get to where you want to be. Right there. Lock it down. Now we have a lot of weight offset here, so it's going to shake like crazy at high RPM. Plus this is a high-speed bit, not a carbide, so you have to run at slower speeds. So I need to make sure that we are not going too fast. So 13 RPM might be too much. I would drop it down to 600. Okay, which direction we need to go? Okay, the cutter needs to go this way, not that way. Get down to about 500 RPM to quit shaking. Cutter down close. Bring it up till it touches. And there it just touches, a little extra. See how much of a chamfer you actually put on there. Not much. So we'll go a little extra. Do another 4th thou. There. Okay, that gave us a pretty good edge break. Oh yeah. So now you look in there, you can see there's a pretty good chamfer in there right now. Right there. So you can see there's a chamfer right in here, break the edge is what you're doing. Now the cylinder should sit down on there flat.
Working back there?
Yeah, I'm back here working. Okay, now I'm going to change out our cutter here. Fly cutter in. What do you need?
Well, go ahead. I'll wait till you take a break. I just want to ask you a couple questions.
Break? I never take breaks. You watched my videos before?
Yeah. I like that one, that 79 shovel, the flame job. That was...
Oh, yeah,
got a lot of complimentary comments.
I don't think they were complimentary.
Well, I'm just being facetious.
Someone else there? Alright, more customers. We'll be back.